Section 4.3, two complex solutions. So this is a problem of solving an initial value problem that involves a second order differential equation which is homogeneous because the right side is 0. So first of all, we have to find the general solution. So to find the general solution, we need to write the auxiliary equation. So the auxiliary equation for this given differential equation is going to be r squared minus 2r plus 26 equal to 0. So this equation cannot be solved. Cannot be factored. Can be solved, but cannot be factored. So we're going to be, we need to use the quadratic equation, which is negative b plus or minus square root of b squared minus 4ac divided by 2a. So in this case, we have 2, because b is negative 2, plus or minus square root of b squared, which is 4, minus 4 times 1, which is the value of a, times 26. Everything divided by 2 times 1. So we're going to obtain 2 plus or minus square root of 4 minus 104, which is equivalent to 2 plus or minus square root of negative 100 divided by 2, and then simplifying, you know that square root of negative 100 is 10i, so we're going to have finally 2 divided by 2 is 1 plus 10i divided by 2 is going to be 1 plus or minus 5i. Okay, so these are our solutions. We're going to have 2, by the way. R1 is 1 plus 5i. Our R2 is 1 minus 5i. So these two solutions are complex solutions. Complex because they involve I. So when the solution of the differential equation is complex, then the general form of the solution is going to take this form. Y equals to e to ax times c1 cosine of beta x plus c2 sine of beta x. Okay, so in our case the solutions are complex, so the shape of the solution is going to be like this because the roots or the solutions of the auxiliary equation are complex. So in this case, a would be 1 and beta would be 5. Okay, because the solutions of the auxiliary equation are of this form: a plus or minus beta I. A is 1 and beta is 5. So our general solution is taking this form: y of x equals to e to 1x times c1 cosine of beta, and beta is 5x, plus c2 sine of beta, and again beta is 5. So that's the general form of the solution. So we need to solve the initial value problem that involves two conditions. One condition is y at 0 is -1. So y at 0 equals to 1 implies that 1 or -1 is -1. So let's fix this. Y at 0 is -1. So this implies that -1 equals to e to the 0 power times c1 cosine of 5 times 0 plus c2 sine of 5 times 0. This is 0. So this is 1, right? Anything to 0 power is 1. So, and then this is 1. Cosine of 0 is 1. So we have that c1 is equal to -1. So we have another condition that involves the derivative, and that is given in the problem. The other condition is that y prime at 0 is -3. Y prime at 0 is -3. Well, uh, to use this condition, we have to apply the product rule to the general form, because general form uh, involves a product of an exponential and a parenthesis containing trigonometric functions. So we have that y prime is equivalent to derivative of the first, right? Derivative of the first is e to the x times the exact same second function plus derivative of the second function. Derivative of the second function would be derivative of the inside of the parenthesis, which is -5 c1 sine of 5x plus 5 c2 cosine of 5x times the exponential. Okay, so then replacing the condition, the given condition, then we're going to have that -3 is equal to what? Well, we replace the value in the equation, right? And then we have -3 equals to e to the 0 is going to be 1 times cosine of 5 times 0 is going to be 1 times c1 is c1 plus 0, because when you replace x by 0 in the sign is going to be 0, plus -5 c1 times sine of 5 times 0. Sine of 5 times 0 is going to be sine of 0, which is 0, plus 5 of c2 cosine of 5x, and x is 0. When you replace x by 0, the cosine is going to be 1. Then we're going to have 5 c2, right? So we have -3 equals to -1, because c1 is -1. We found c1 equals to -1 plus 5 c2. And then we isolate c2. We move the -1 positive to the other side. -3 plus 1 is going to produce a -2, and then we divide by 5. So c2 is -2/5, and then the solution of our initial value problem is going to be y of x equals to e to the x c1 is -1, so it's negative cosine of 5x, plus c2, and c2 happens to be -2/5 sine of 5x, and this completes the problem.